Trig unit, page 1. Exercise 1G, number 1. Find the length of the unknown side in each of the following right-angled triangles. Round your answers to 1 decimal place. We're going to be using Pythagorean's theorem, which is a squared plus b squared equals c squared, where c is the hypotenuse. Find the length of the unknown side. So let's look at this first one. So since the hypotenuse is c, w is going to be c. It doesn't really matter if you make this a and this b, or if you make this b and this a, because the only thing that really matters is the hypotenuse is c. Okay, so let's just do it like this. 12.2 is going to be a, 13 is going to be b. So when I substitute it into a squared plus b squared equals c squared, I get 12.2 squared. 13 squared, oops, equals w squared, or c squared. And so let's solve for c, or w now. I'm going to put w instead. So let's put this in the calculator. We're going to simplify the left side. So 12.2 squared plus 13 squared equals 317.84. So we have 317.84 on the left equals w squared on the right. Let's take the square root of each side. Then we're going to get just w on the right side, and the left side is going to be square root of 317.84. The answer is 17.8. 3 sig figs. Okay, next one. Part B. Again, we're going to be doing a squared plus b squared equals c squared, and the only one that has to be is c. The 9.7 has to be c. This is the hypotenuse. The hypotenuse you can recognize in 2 forms. One is it's the longest side. The other is it's opposite from the right angle. Either way, it's the hypotenuse. Let's take a look now at the others. So since this one's already called b, why don't we call this one a? So now we have a squared plus b squared equals c squared. Remember, c squared has to be the 9.7 squared. The a squared is going to be 6.1 squared, and then of course b squared is unknown. 6.1 squared, we did that on the calculator here. 6.1 squared appears to be 37.21 b squared. 9.7 squared appears to be 94.09. Do a little bit of algebra. We're going to subtract 37.21 from both sides. Get b squared equals 94.09 minus 37.21. 56.88. Why don't we take the square root of both sides? Undo the squared. Square root of 56.88, 7.54. Okay. Part C. Again, Pythagorean's theorem. This one's already called A. Let's call this one B. And of course, the hypotenuse is little c. So we have a squared plus b squared, which is 3.5 squared, equals c squared, which is 7.5 squared. So a squared is equal to, let's simplify, actually, we'll simplify first. So 3.5 squared is that. 7.5 squared is that. So let's type those, let's write those in. A squared, 3.5 squared is 12.25 squared, 12.25. 7.5 squared is 56.25. Going to subtract 12.25 from both sides. And I'll get a squared equals, and then this will be like 44. 56.25 minus 12.25 is 44. Square root, and now I'm going to take the square root of both sides, right? Square root of 44 is 6.63. Let's go to D. Once again, another Pythagorean theorem. Of course, the hypotenuse is C. Now this is a little confusing because they called this one C. We can't call this one C anymore. Let's call this A, and we'll call this B. So let's see, A squared plus B squared equals C squared. So that means A squared plus 9.5 squared equals 14 squared. 9.5 squared, let's do that on the calculator. And 14 squared, let's do that on the calculator. 196. So we'll have A squared plus 90.25 equals 196. I'm going to subtract 90.25 from both sides. A squared equals 196 minus 90.25. 105.75. Let's take the square root of both sides. Square root of 105.75 is 10.3. Actually, we originally called this C. So its C is 10.3. All right, number 2. What we're going to do here is we're going to test to see if these three sides in each one of these is possibly a right triangle. How do we check that? We check it by doing A squared plus B squared equals C squared. If it's a right triangle, the three sides should obey the Pythagorean relationship. Okay, remember that C is the longest side. So for this one here, I could do ABC. Square root of 200 is going to be bigger than 10 at least, right? Because 10 squared is 100, so this I could also do ABC. This one's also ABC. And last of all, look at this one's tricky. This is the longest one, so this is C. Okay? So what I'm going to do is I'm going to test to see if the left side, A squared plus B squared, A squared plus B squared is equal to the C squared. So let's do that for each one. So for the first one, we're going to have 9 squared plus 40 squared, and we're going to check to see if that's equal to 41 squared. 9 squared plus 40 squared, it's equal to 1681. Let's do 41 squared. It's equal. Okay, so this one is fine. Yes. Right angle triangle. 10, 10, and square root of 200. So we do 10 squared plus 10 squared. And square root of 200 squared, of course, is also 200. So this one is also okay. What about 10, 24, and 36? 10, 24, and 26. So we'll do 10 squared. 10 squared is 100. 24 squared, that's equal to that, 676. What about 26 squared? 26 squared is also 676, so this one is also okay. What about D? 7.5, 8.3, and 11.2. So 7.5 squared, 8.3 squared, is equal to 125.14. What about 11.2 squared? 125.44. So no. Okay, all right. Let's see. Number 4, a right-angled triangle has a hypotenuse of 8.2 and another side length of 4.3. Draw a diagram, calculate the area of the triangle. Okay, so hypotenuse of 8.2, side length of 4.3, right-angled triangle. Calculate the area of the triangle, give your answer correct to 1 decimal place. So first thing we're going to have to do is we're going to have to figure out the length of this unknown side. A squared plus 4.3 squared equals 8.2 squared. Once we figure out the length of this side, then we could do 1/2 base times height, which is the area of a triangle, right? So let's find 4.3 squared and 8.2 squared. on the calculator. And then we'll plug those in. So we have a squared plus 4.3 squared, which is 18.49, equals 8.2 squared, which is 67.24. We're going to subtract 18.49 from both sides. And we'll get a squared equals 67 minus 18. 67 minus 18. 48.75. So let's take the square root of both sides. What's the square root of 48.75? 6.98. Okay, so we have this side at 6.98. Now we could use 1/2 base times height, which is the formula for area of a triangle. So 1/2 times the base, which is 4.3. This is review, so I'm not going to take too long with this. Multiply all that together. 1/2 times 4.3 times 6.98. So 1/2, which is 0.5, times 6.98 times 4.3. So the answer is 15.0. So that's the area. Correct to 1 decimal place. 1 decimal place. Number 1, determine the length of the unknown sides for each of the right-angled triangles below. So now we're going to start using SOHCAHTOA. SOHCAHTOA. Which one are we going to use? Let's see. This is the hypotenuse. The adjacent side is right next to the angle. And the opposite side is opposite from the angle. So we have the O, A, and H marked. The relationship that we probably want to use would be related to which ones we want to know. So we know the angle, we know the hypotenuse, and let's see, we want to know both of the unknown sides. So let's find the opposite first. So if we want to find opposite and we know hypotenuse and the angle, the relationship, which has O, H, and the angle, would be sine, right? So the sine of theta is equal to opposite over hypotenuse, theta being 61.2 degrees, opposite being y, and hypotenuse being 9. Sine of 61.2 is oops, I have to put in mode degrees. Good lesson for you. We always put mode degrees first. Then I type it in again, sine of 61.2. And then I get a reasonable mode number, 0.876. Y times 9. So y is equal to 9 times 0.876, which is equal to 7.89. So that's my value for y. What about z? Z I can find because I want to know the adjacent and I know the hypotenuse. That would be cosine. So cosine of theta would be cosine of 61.2 degrees. The adjacent is z in this case, and the hypotenuse is 9. So cosine of 61.2, we can find that with the calculator. It's equal to 0.482. And then I just multiply both sides by 9, right? Then I get 9 times 0.482, and that's equal to my z value. 9, times 9. Oops. Why didn't that work? Times 9. 4.34. Okay? All right. Next one. So we want to know x and z, and we have this angle. So the hypotenuse is z. This is the opposite, and this is the adjacent. So let's do sine first. So we'll do sine of 34 degrees is equal to the opposite over the hypotenuse, which would be 10.2 over z. Sine of 34, let's do that on the calculator. 0.559. 0.559 equals 10.2 times z. We have a variable in the denominator. How do we get it out? We're going to do cross multiplication. 0.559 times z is equal to 10.2. So z is equal to 10.2 divided by 0.559. 10.2 divided by second answer, 18.2. So z is 18.2. That's the hypotenuse. Now let's find the adjacent. The adjacent we can find using, now that we know the hypotenuse is 18.2, we can figure out the adjacent using cosine. Cosine of 34 degrees is equal to the adjacent x over the hypotenuse, 18.2. Cosine 34. 0.829. Now I can multiply both sides by 18.2. So x is equal to 18.2 times 0.829. 15.1. All right, last one. So this, of course, is the hypotenuse. The opposite from the angle, of course, is opposite, and so the remaining one is adjacent. Let's find hypotenuse first. We know the opposite, so opposite hypotenuse, that would be sine. So the sine of 66.4 degrees is equal to the opposite divided by the hypotenuse, which is y. Sine of 66.4, I can do that on the calculator. Oops. .916. We can cross multiply to get the variable out of the denominator. So y is equal to 21.3 divided by 0.916. .23.2. That's y, which is our hypotenuse. Let's find x now. We can find x using, since the adjacent, we can use it finding cosine. Cosine of 66.4 degrees is equal to adjacent, which is x, divided by the hypotenuse, 23.2. Cosine of 66.4, let's use the calculator. .400. Let's use no, we don't need cross multiplication. All we need to do is multiply both sides by 23.2. .929. That's our x value. Okay, that's it.